Okay, so this is the page 4, figure 1, an illustration of agentic system which with different modes of agency. Left, language model agency. The language model acts both as the HCI, which is HCI is human computer interface. Okay, so and the orchestrator. So the language model acts both as the HCI and the orchestrator of tool calls to carry out a task. And right is the code agency. This one basically. The language model fills the role of HCI optionally, while a dedicated controller. This is the controller here. Controller dedicated controller code orchestrates all interactions. Now in the left side one, there is an LLM. It might call tool 1, tool 2, or it might call another LLM, but in all the cases the response goes back to the LLM. In case if it calls an LLM, then the LLM will further call other tools like tool 3 and tool 4. In case of the right hand one, there is LLM, and then the controller. It looks like more of a deterministic or rule based something which calls tool 1, tool 4, tool LM, but not much description is given about this. Okay, so I'll move ahead. NVIDIA Himba 1.5 billion. This Mamba Attention Hybrid Head SLM demonstrates best instruction accuracy and 3.5x greater token throughputs than comparably sized transformer models. On instruction following, it outperforms larger 13 billion models. DeepSeek R1 Distill series. DeepSeek R1 Distill is a family of reasoning models featuring 1.5 to 8 billion sizes trained on samples generated by DeepSeek R1. They demonstrate strong common sense reasoning capabilities. Notably, the DeepSeek R1 Distill 017 billion model outperforms large proprietary models such as Claude 3.5, Sonnet 1022, and GPT-4o0513. DeepMind Retro 7.5 billion. Retrieval Enhanced Transformer Retro is a 7.5 billion parameter model augmented with an extensive external text database, achieving performance comparable to GPT-3 175 billion parameter on language models while using 25x fewer parameters. Salesforce X large to 8 billion. The 8 billion model achieves state-of-art performance on tool calling despite is relatively modest size, surpassing frontier models like GPT-4o and Claude 3.5s. Note that on top of competitive off-the-shelf performance, reasoning capabilities of SLM can be enhanced by lightweight selective fine-tuning. So we'll have to do fine-tuning definitely, or at inference time with self-consistency, verifier feedback, or tool augmentation. For example, tool former 6.7 billion outperforms GPT-7 175 billion via API use, and 1 to 3 billion models have rivaled 30 plus billion LLMs on maths problems via structured reasoning. In sum, the modern training, prompting, and agentic augmentation techniques capabilities, not the parameter count, is the binding constraint. SLM now supplies sufficient reasoning power for a substantial portion of agentic invocations, making them not just viable but comparatively more suitable than LLMs for modular and scalable agentic systems. Coming on to section 3.5, SLMs are more economical in agentic systems. A2. SLMs are more economical than LLMs in agentic systems. This argument supports view V3. Small models provide significant benefits in cost efficiency, adaptability, and deployment flexibility. These advantages are specifically valuable in agentic workflows where specialization and iterative refinements are critical. Section 3.1 detailed a number of efficiency comparison on the listed SLMs to relevant LLMs. Here we draw a more encompassing picture to support argument A2. Inference efficiency. Serving a 7 billion SLM is 10 to 30x cheaper in latency, energy consumption, and flops than a 70 to 175 billion LLM, enabling real time agentic response at scale. Recent advances in reference operating systems such as NVIDIA Dynamo explicitly provide support for high throughput, low latency SLM inference in both cloud and edge deployment. In addition, since SLMs require less or no parallelization across GPU and nodes, the maintenance and operation of the serving infrastructure comes at a lower expense as well. See counter argument CA4 and argument A13.